Hello guys, let's start with another problem which is known as happy number. So what is happy number? A happy number is defined by the following process that states that starting with any positive number, replacing the number with the sum of the square of its digits and repeating the process until and unless we get a number equal to 1 or its loop endlessly in a cycle which does not include 1. Got it? If the number excludes with 1, then it is happy, otherwise it is not. So here we can see the example. What we are doing, that we have taken a number n equals to 19. If we take out each and every digit of 19, it would be 1 and 9. If we do the square of each digit, 1 for it is 1 and 9 for it is 81. Total 82. Same with 82. If we do the square of 8, it would be 64, and for 2 it would be 4. 64 plus 4, 68. Again we'll do the square of 6 and 8. So for 6 it is 36 and 8 it is 64 again. If we'll add it, it is 100. And if we'll do the square of each digits of 100, we'll get 1. So hence it is making it a happy number. If we see the another example of n equals to 2, it is false because it is not a happy number. It is not a happy number. So here comes our logic. What we can do? We can use recursion. And what is recursion? Recursion means calling again and again the same function multiple times unless and until we reach to the end, either to the resultant positive or negative, as in this case. If at last we are getting 1, so it is happy number, otherwise it is not. So in our base case, we can say that if n is equals to 1, then it is happy number and we return true. Otherwise we return false. But otherwise when we return false, that is the catch. Here is some interesting thing which you can keep in mind is that opposite to happy number, there is unhappy number. And if n is equals to 4, then it is unhappy number. That means this condition could be our else part. Okay, we can return false in this condition. Got it? Here is the catch. Apart from that, we will loop around the n and get each and every digit from the whole 2 or 3 number digit, a single digit from the whole, square it, add it into the other one and loop around again and again until the digit becomes a single digit number. Got it? So let's start it. Should I start or should we deep dive into recursion? When I'm talking about recursion, what's happening here? Each and every answer that we are getting at the end of the loop and we are putting it again, if it is not a single digit number, into another recursive call of calling this particular function is stored in a recursive stack. Remember, it is stored in a stack. Got it? So let's start our approach. So if n is equals to 1, return true as the number is happy number. Else if n is equals to 4, then return false as the number is unhappy number. Got it? Otherwise, we can take a variable sum where we store the square of each single digit of the number and check whether it is happy or not while using a while loop. N is greater than 0, then int r is equals to n mod 10, give us a last digit number, or instead of r, let's take it first digit only so that we can remember the logic. And in sum we will add the square of the last digit. So it can be calculated by multiplying last digit by itself again and adding it into the sum. And now n is divided by 10 so that we can get a new value of n. At last we'll call this is happy function again, putting the value of sum in it. Here I was talking about recursive call and stack is used. Got it? Let's try to run it. See, it is giving exactly fine. Let's try to submit it. It got submitted. Now let's talk about time and space complexity. So time complexity is log n to the base 10, as each time we are dividing our digit n with 10, and at last that digit, if it is not single digit and we are not getting into the conclusion of whether it is happy or not, we are again calling the happy number. So we are recursively calling our happy number with log of 10 with the base of 10, log of n with the base of 10, right? Just like that, our space complexity is also log of n with base 10. Why? Each time when we are calling again and again our is happy function with sum in it as n, we are making recursive call and putting our return data into a stack. So log of n time data is put into two different stacks. So that's why our space complexity is also big of n with base 10. So hence time and space complexity both are log of n with base 10. Got it? Signing off. Bye bye.